All right, kids, section 6.2. There's an opening problem here. I'm not going to do this. There's nothing new here. And I'll post these solutions in the regular spot later. If you feel like messing with it on your own, it's just 8 steps. Okay. I'm going to talk about this next one, though. It says, try to draw a diagram from the following. You should maybe stop this and try to do it yourself first. Sorry that you don't have much room here. It says 2 circles intersect at 2 points. So there's one circle. Not my best circles ever. Okay. The segment joining the center of the circles, that's that one, bisects the segment joining the points of intersection. Remember, the points of intersection are here and here. So we're talking about that segment there, right? It says the segment joining the centers of the circles bisects the segment joining the points of intersection. Okay. And it says, is this always going to be the case? In other words, is it always going to be the case that this is congruent to that? And you should think about this for a moment. And I'm going to talk about it here. This is always going to be the case. And remember, we can prove this. We could draw in some radii. So we could prove this big upper triangle congruent to this big lower triangle by SSS because they have this reflexive piece in the middle, right? That would then allow us to say that this angle is congruent to that angle. Now I could prove triangle ABD congruent to triangle CBD because SAS, we got this reflexive BD now, right? So then these two angles, so then that would force AB to be congruent to BC, right? So there you go. We just proved it every single time. We just created that. Notice how we created that diagram from scratch. And as the title implies to this worksheet, we are going to be doing some problems without a given diagram. We have to create the diagram. We actually have to set up the problem. Okay, so let's take a look at this one here. This is for the following: draw and label your own diagram and write given proof statements, blah, 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 blah. Now, the next thing I'm going to say, you probably never thought you'd hear about in math class. The median to the base of an isosceles triangle is also an altitude. Where's the verb? Boom. Right there. Everything before the verb is the given, right? And everything after is the prove. So let's draw. Okay, I know I'm pretty boring here. We have an isosceles triangle, ABC. This is M. And it says the median to the base of an isosceles triangle is also an altitude. So in my given, I'm going to say that I was given what? Isosceles triangle ABC with base BC. And then I'm also given that I have a median, so AM is the median. So all that's given. And then the prove would be AM is the altitude. Okay. So you're looking for that. Sometimes it's very obvious what the given and prove are. Sometimes it's not. You're looking for the verb in this case, and everything beforehand is the given typically. And now you're asked to prove it. I mean, we'll do some of this stuff in class. You can do it yourself. I'm not going to do it here on this video. I had 8 steps for this one. You can check it on the solution document that I post, of course. I just wanted to talk about the setting up. So here, the altitude to the base of an isosceles triangle bisects. So this, there's the verb. Everything beforehand is the given. So we have another isosceles triangle. And the altitude to the base, I'll call that D. So it says we have an isosceles triangle. So again, we can almost do this all at once. AD is the altitude of isosceles triangle ABC with base BC. There's our given. And again, this stuff here that comes after this verb bisects the vertex angle. That's what we have to say in our prove and for our conclusion. AD bisects angle BAC. Okay, so that's our setup, and I think there's different ways you can do this. Let me see here. We have an altitude. So I have 7 steps using HL. I think you have to use HL here, I believe. So that's what I had if you want to practice. Okay. You guys at this stage should be able to figure it out yourself. Now this one here, I'm going to talk about this one. If all 4 sides of a 4-sided figure are congruent, so let's draw. A lot of times people draw a square, but I don't want to draw a square because a square is very special. I'm going to draw the least special thing I can, but still 4 sides congruent. And A, B, C, D. And it says the segments opposite, the segments connecting opposite vertices are perpendicular. So remember, if this is very obvious, right? If all 4 sides are 4-sided, so that's the division between your given and your prove right away. Now, so it says they're all congruent. So I would say AB is congruent to BC, is congruent to CD, is congruent to AD. And what are we? The segments connecting opposite vertices are perpendicular. That's what we have to prove. We have to prove AC is perpendicular to DB. Okay. This proof here, let's see here. Boom, 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 boom. Okay. And this one's kind of tricky. I would do 2 sets of triangles. So in other words, in my step 2, I would have AC congruent to AC, comma, BD. I think I'm going to need both of these. Obviously, that's going to be reflexive. Step 3, AC. So I can prove triangle ABC congruent to triangle ADC, and at the same time, I can do triangle DAB congruent to triangle DCB. This is all by SSS, of course. Now, what can we take from those to help us? We have to show perpendicularity. Actually, you know what? I take this back. I think we can just do 1 set of triangles. In other words, if I just did, I can prove this. I get this congruent to that CP-CTC. So I'm actually not going to need, I see a way of doing this. I don't need that. And I don't need this. What I do need, and you'll see where I'm going with this, I'm going to call this some point. Let's call this M. AM is congruent to AM. See, now once I take angle MAD congruent to angle MAB by CP/CTC, I can now say that triangle MAD is congruent to triangle MAB by SAS. And then I can take the angles in the middle, angle AMD congruent to angle AMB. Remember, I have to show that they're right. And that's by CP/CTC. And then, of course, it looks like I'm going to have 8 steps in step, or maybe 9. Wow. So here I have to say that angle AMD is sup to angle AMB. You know the reason there. Now I can say that angle AMD is right, because if angles are sup and congruent, then they're right. Now I can say that AC is perpendicular to DB. So ends up being pretty lengthy. And this last proof, folks, I'm going to let you do this one yourself. Try to set it up. You can check my document on Canvas. I have 5 steps for this one, but you got to set it up first. All right.